There we go. Okay, so today, today and the rest of the week, we are going to talk about topic 12. Topic 12 is going to be the last one before our test next week. Okay. And I think you'll see if you've looked at Jupiter, I have put in for a week from today a quiz over topic 11 and 12 as we prepare for the test. Okay. So be mindful of that. Perfect. 2, 3, 1, 2, 3, 1, 2, 3. Two. Okay, so within each unit, we have looked at equivalent representations. So like when we did like, you might remember in unit 1, we did like polynomial long division. We saw how polynomials and rationals were connected together. We factored, we found poles. We also did manipulation with exponentials using transformations, as well as logarithms using transformations, and manipulating those things to find equivalent representations. So now is our turn to do equivalent representations of trigonometric functions. Now, there are a few things that are important to point out here. Just go like this. Then I'll close that. The reason that we're taking 4 days to work on this, like 3 days of learning about it and a work day on Friday, is because I think out of all of the lessons up to this point, this is probably one of the most challenging ones, because there are a lot of expressions and formulas that you're going to need to remember. I won't give them to you for the quiz. I will not give them to you for the test because you're not going to be given them on the exam. Okay. So something that if you've not used them yet this year, flashcards, writing down the different identities and working on memorizing them will only to be your benefit. Heck, if you want to make a Quizlet and share with the rest of the people in class, that is great. Okay. Equivalent representations of trig functions. The main place that you're going to see this on the AP exam, wow, free response question number 4, okay? Because it is that 4th free response question that's dealing with simplifying expressions and solving equations, okay? So that's where you're more than likely going to see all of this. You could see this in a multiple choice, like solving an equation. Yeah, free response question number 4 is definitely going to have some of this there. So we have, because this is such a large lesson, there are 3 objectives. The first one is we're going to rewrite trig expressions in equivalent forms with something new. It's called the Pythagorean identity. It's really neat, really cool. How we understand it is actually easier than what it said, or it might seem. Number 2, we're going to rewrite trig expressions in equivalent forms with sine and cosine sum identities. And then last one, solve equations using equivalent representations of trig functions. Okay. So when we hear the word identity, the only other place that we have really seen the word identity is actually back in algebra. I know that sounds silly, but it's true. An identity are 2 expressions that are equal to one another. For instance, that is an identity. x plus 0 equals x. That is identity. The right side and the left side are equivalent to one another. Another example could be when we factor quadratics. The left side and the right side are equivalent. Okay, so those are some examples of what an identity is. Okay, when you do like the 1 over x times x equals 1, the like reciprocal, that is an identity. Now, as you see in your notes, and as we see peeking through, we know a lot of identities already. Okay, every single function that we have seen so far is an identity. Sine being 1 over cosecant, secant being 1 over sine, cosine 1 over secant, secant 1 over cosine, tangent 1 over cotangent, tangent sine over cosine, cotangent 1 over tangent, cotangent cosine over sine. These are all identities that we have already seen from the first part of the unit into the second part of the unit. Okay. So what we're going to do is we are going to work on simplifying some of these expressions. Now, here's the nice thing. Okay. Before AP Precalc, this lesson was so hard. It was so hard because you didn't know when to stop simplifying. You didn't know what the most simple expression would be. Here's where this is different, not just in these notes and in the homework, but on the AP exam as well. They tell you how you should finish. So we're going to use these identities to manipulate and rewrite these expressions in equivalent forms. So here's the first example. Let f of x equal sine of x times secant squared of x over cosecant of x. We're going to rewrite f of x as an expression involving tangent and no other function. And no other function. So let's walk through it. The first thing that we will do when we start to simplify is, for the most part, we will try and plug in what we can and with sines and cosines. For example, sine of x times secant squared of x. So this is equivalent to sine of x. What is secant squared the same as? 1 over cosine squared. Okay. Now, I'm dividing by cosecant. What is cosecant the same as? Of the sine. So I'm going to write it like this first. Okay. So that first step, I replace expressions with sine and cosine. That is the general first step that you will. Okay. That is not always the case, but generally speaking, that's a good first step. So now this is where our algebra skills, like when we solve equations and inequalities, this is where our algebra skills really come into play. For instance, when I divide by a fraction, what is that the same as? Multiply by what? The reciprocal. So this expression is the same thing as sine of x over cosine squared of x. Okay. What's the reciprocal of 1 over sine? Sine. If you want to put the 1, you would do that. Ooh, this has just become a lot easier and much more simple. Okay, well, what is sine x times sine of x? Sine squared of x. Sine squared of x over cosine squared of x. Ooh. Now, here is where this last piece of the instructions becomes really handy. It tells me rewrite f of x as an expression involving tangent and no other trig function. What is sine squared of x over cosine squared of x the same as? I'm thinking about doing. It is pretty neat. Knowing how they want us to write it, makes these problems so much easier. It's like, so like when it wasn't AP, we would have like simplifying expressions